Welcome, DJ.
Thanks for having me. At least the only thing I can say is that my attempting to recruit you is a sign that actually I could choose people correctly. So one of the things that I thought that might be useful to talk about here, especially given that so many people that are here at Stanford, particularly in the faculty and the students, have heavily impacted my work, and this is one of the places I come to look at the students' work, to get ideas, to get inspiration. I was thinking, well, what should I actually tell you that's useful? Because a lot of the design principles have really been formalized here. And so I thought maybe to shift it a complete different way and to talk about some of the challenges that we see in the data space, especially for the students that are going out to go into industry or thinking about helping out in industry, to give you a framing on which to actually be productive in those environments. And so to start with that, I think one of the things that we have to talk about is there's a tremendous amount of hype out there right now. And so what's the truth, what's the hype, and where's in between out there? And when we think about that, this last year has been a pretty remarkable year for data. I mean, who would have ever thought that people would even have this idea of talking about data on NPR? I mean, that was not a realm that was really possible a few years ago. And then you get into things about all these magazine covers. It's, when you're on the front of Harvard Business Review, either we've jumped the shark or it's a great new world coming. And I think a lot of it is actually due to Hollywood. Hollywood has done us a tremendous service in talking about what is out there. I mean, I can't tell you how many times at Greylock, where we're a venture firm, may have seen a lot of the companies we help out with, like LinkedIn, Facebook, Dropbox, Tumblr, a lot of these type of companies, where people will suddenly come in and they'll say, well, we're the money ball of this. I mean, that's sort of like a standard pitch. People talk, oh, well, that's Moneyball of that. And I think a lot of it is it's helped people in the public to understand what does it actually mean to be data-driven. They've kind of got this idea. Data can be helpful. Data is not something I should be afraid of, but it's something that can actually make me better. It can help improve me. And with that, we've seen a sort of big natural events, Hurricane Sandy. It was impossible 10 years ago to show the different forecast lines. So these are the different, what's called an ensemble forecast of all the places a hurricane can go. That was not okay to show 10 years ago. It was not okay to talk about ensembles of forecasts. That was a policy choice. Now it's like if you don't see the different ensembles, you think, wow, that's a terrible model. I want to understand the uncertainty. Understand the uncertainty of the range of things that can happen. That is now natural. That is a radical shift over the last decade in how people even think about presentation of weather forecasting. Not how they did weather forecasting, but how they talked about it. And it's about how we convey that information. Recently, we've heard all this stuff about security, particularly on national security front. Even the events last night, we're hearing about how people are putting data together in new ways. All the work that was done behind the scenes to find Osama bin Laden, all the talk that people actually bringing data together, a lot of privacy questions in this, all sorts of interesting things are coming up. It's all about that data, and data is front and center in that question. And of course, we had an election last year, and that was this radical transformation moment of where and who was responsible for helping. And so there's a lot of talk with people like Harper Reid, who is the CTO of the Obama campaign, and being really responsible for bringing in people with a lot of experience around data, how to bring in data technologies, and to use data for big change. And of course, with that, it was the Moneyball campaign. And it didn't just stop there, because then you had people on the outside, like Nate Silver, talking about data and suddenly taking on all these classic pundits, and they were saying he's wrong, and he's like, I stand by my data, and look, at the end of the day, he wins. Data trumped all the expertise and all the evidence. And yet, at the same time, you look at that graph, and you're like, that's a pretty crappy looking graph. So we're in this kind of interesting space where people really start to appreciate the data, but how do we actually interact and work with it? Well, we got these books of big data. I don't know what we're talking. Well, anyway, it's Revenge of the Nerds, so we're winning. It's about time. One of the other things I want to mention here is that oftentimes we think of those as data products, but I think we have to actually much more broaden our way we think about that. Because there's also this time where we're starting to instrument a lot more things. We're instrumenting ourselves and how we actually measure ourselves. We've got all these devices like the Up. Unfortunately, the Zio just went out of business, or I think it's out of business. I don't know. One of my favorite ones, though. You got these blood pressure monitors. We got these scales. We got all these kind of great things that are measuring more and more out there. So we're trying to be in a data-driven world. We're supposed to do Moneyball for our health, but it's still hard. There's a lot of challenges in there. And we go into physical devices. Get the Nest thermostat device, you put it in, it tries to get smarter by listening or sort of sensing what's happening in your house. We have the self-driving cars, all this kind of stuff. I mean, Curiosity is a big data thing, sitting on another planet, taking on all this remote sensing data, trying to understand what's actually out there. And so we got all these kind of cool new things where data is coming off in really big ways. And there's some places where we don't even realize it's happening. Take together these planes. Right now there's about 20,000 planes operating, 43,000 engines spinning. We're going to have 3,000 more in the next 15 years. A lot of these spinning. And the latest engine, this is the GE NX engine. It's a big engine. I mean, if you put it in this room, it would probably reach the ceiling. It is massive. But the cool thing about this, and if you can actually look up on YouTube like what it looks like when you fly this thing. They have these test chambers where they try to simulate it going through a storm and how much water they got to dump on this thing. It's crazy. But this thing is throwing off 290 parameters 16 times a second. At the end of the flight, you're getting terabytes of data off these systems. And so what are you supposed to do with that? And so we start to get into this interesting space of talking, can this engine tell us proactively that it's sick? Can the engine start to help us better understand what's happening in different parts of the world so that people might change their flight patterns? Could we actually understand climate change better because this thing's got so many sensors on it? We start to get into all these interesting things. The big thing at the end of the day of all this is that all these things are data products. And for me, what a data product is, it facilitates an end goal the way it does it with data. You'll notice something interesting. All these products, not one of these has a graph. There's no dial, there's no sort of magic sort of infographic around all these things, but they're all super sophisticated data products. And so the thing I was thinking about talking about is like, well, how do we actually build data products? Where are kind of all those lessons we learned? And if this is all the cool stuff that's happening around data products, why aren't we seeing more data products? What's the gap? Where's the gap of all the problem we have? And I think one of those first gaps is working with data. And I think the best way to put it was by Dan Ariely here. And his quote is, big data is like teenage sex. Everyone talks about it. Nobody really knows how to do it. Everyone thinks everyone else is doing it, so everyone claims that they're doing it. It's kind of like insert Hadoop here, right? It's like, it's this problem. Like we're all talk about the infrastructure. We got all these things, but we got this kind of fundamental challenge of like, okay, how do we work with these things? What is all these pieces of the puzzle? And it gets to even be more, how do you build a data product at scale? Building a data product at scale is literally like trying to give a cat the bath. It is really, really tough, and there's unexpected consequences. It's very easy to put a hack together, to put something together, a hackathon, but how do you build something at scale? What's at scale? I'm talking LinkedIn, Facebook, eBay, Google scale, building products at a scale. And so what I want to do was spend time talking about, these are the set of things that I really wish I knew going into this. And if I was saying, this would be my things of take this away as you go in to build data products. And that first one is to think about, as you build a data product, it's got to be a strategic arc. You have to think about the product as an arc. Another way to say this is you don't try to climb Mount Everest on day one. You start with the dish, then go to something taller, Mount Diablo, and finally eventually you work your way up there. And so what I'm going to walk you through is over a progression of the beginning portion of LinkedIn and how we actually thought and actually how we built a product portfolio. A portfolio of products that built on top of each other to get us to that Mount Everest cycle. That sort of claimed, ooh, we should be able to do things in real time. Right? That kind of level. And so the first lesson there is you always have to be very conscientious of what data you start with. What's structured, what's unstructured? What can you get structured, what can't you get? And how do you start working with that? Well, an example of that is to think about how much of that heavy lifting, this is like It's like a promo slide for Trifacta. Put a logo. The heavy lifting, this is such a big problem. I can't emphasize how painful it is and how much time goes into this. I'm just trying to clean and prep the data. Give you an example of that. Here's an old LinkedIn profile of a person. And you'll notice on here there's a number of variations of IBM. Take a gander how many variations there might be of IBM. Any ideas? Tens? 100? Try north of 6,000, 8,000. Why? Why so many? We got IBM. We got IBM Research. We got things like SPSS, Netezza. We got IBM Almaden. We got all the subsidiaries, all the different, but somebody might say consulting. Maybe someone wants to spell out international business machines. When you're building a system like this, we could control it, right? You come in, log in, you say, oh, well, what company are you in? And you're like, choose from the drop-down list. You're like, okay, how long would that drop-down list be? Right, that's not going to work. So at this point, this problem is an unstructured problem, right? Or is it? How could we turn this from a semi-structured, unstructured problem into a very structured problem? Well, maybe the first thing we do is as somebody starts typing IB, we have type ahead. And it says IBM. So we encourage them to go during it right way. Maybe after that, we say they still put in something we don't know. Maybe instead what they're going to do is suddenly we say, hey, you know what? We can't find you in the system. Are any of these end companies the one that you're with? And it shows IBM or maybe some of the subsidiaries. So now those are mapped. We have the unstructured text mapped to something. Maybe what we do is we say, hey, we can't find it. Give us your stock symbol. Give us the URL for your company. So what we're doing is we're allowing the problem still to appear unstructured, but we are mapping it to an incredibly structured state. And that trick is massively important to build the product at scale. Why do I say, why is it so important to build it at scale? Because as you start to get at the larger and larger things, the amount of overlaps and collisions that start to happen starts to really cut down on your ability to actually, like when relevancy starts to come up for building something like jobs you might be like, or recommendations for companies you might be interested in. All that stuff starts to break down. So one of the things that's in here is also how to use human augmentation. There's a lot of times we would love to use these systems and just try to throw lots of machine learning at it. And so one of the things we might say is, oh, sure, we could build an extraction layer. We could build all this sophisticated ML. And don't worry, it's only going to take 10 people. 10 people a year. 10 people a year, $120,000 a salary, loaded costs, let's say $200,000. That's a lot of money. Or I might be able to send it to a bunch of mechanical Turkers and let them solve the problem. So how might that specifically work? What I might do instead, let me give you a very classic example of this. Let's suppose I have a bunch of profiles and I have to try to understand which ones of these are fraudulent and which ones of these are good. So now I've got this list, and we could build all the heavyweight machine learning and all the stuff we want. But instead what I'm going to do is I'm going to say, we're going to do some very low-level parsing. Just look for garbage and look for not, and we're going to try to separate those that are obviously bad from those that we're not sure about. And so we just do some lightweight parsing. Okay, great. We did some lightweight parsing. Now we've got the rest of the set. So we've done one layer of cleaning. The next layer of cleaning, what we're going to do is we're going to send it out to mechanical Turkers, and we're going to ask them to give us an upvote or a downvote. We're going to send it to 3 of them. We're going to do it for every profile. It's going to be like 1/4 of a cent each. Okay, so now we got 3 votes. So so now we're going to have a bunch of ones that are fully 100% thumbs up, all 3 votes. Some are going to be all that way, and some that are going to be mixed. Great. We split our bucket into 3 buckets now again. All good, all bad, we're not sure. For that bucket that we don't know about, we're going to send it out to 3 more people with additional content, more richness. Maybe it's now going to cost us 5 cents to do that one. And so now, once again, we're going to get a vote. And then what we're going to do, we're going to repeat it again with much more data. And now it's going to cost us 10 cents. And then finally, we may have a bucket we can't decide on. And what we're going to do is we're going to try to look at it from people inside the company. And then maybe there's another bucket we just don't know what we're doing, and we're going to monitor the hell out of them to figure out which ones are, what they do is their intention right or not. The trick of this process is, during that entire flow, we are looking at what are commonalities. We are taking the commonalities and we're translating that into systems that we can then build. So now we're not building with ambiguity, we're building with intent because we have figured out what types of things we want to replicate. We've seen an action repeated over and over again, we replace that. So total net in to do these type of experiments, you may be only $100,000, $200,000 in to build this stuff, and we know specifically what to build now. That's how we use augmentation to actually get this cadence in our stuff. Always build the easy experiments and things first. We like to often go to the crazy, powerful, sophisticated recommendation engines. Build the lightweight stuff. You know, the easiest one is, and now everyone knows what I buy on Amazon, is you know, the people who viewed this, viewed that, right? Or people bought this, bought that, or viewed this and then bought that, all the variations. This is just a counting exercise. The reason to build this is, think about this. And remember, once again, this is a data product. I don't see any graphs. See any charts? There's no percentages here. Walmart's will put a percentage there, but you don't need it. But there's a lot of, still when you build this, right, this is a giant matrix, adjacency matrix that you're basically building. And then what you do is you suddenly run into all sorts of problems. Because you get sparsity, and you suddenly, it's like people who bought Thomas and his wooden railway also bought something really bizarre, right? And then you're like, whoa, how did that happen? Because you got sparsity, low values in there. And so you got to fix that. And then as you start to fix that, you realize like, hey, wait, even this simple problem actually turns out to be pretty complex at scale. Because now how often can I run this? Can I run it every day? Or can I run it only once a week? Or can I run it every month? What does it take to do this? The first version of this, first version of people who viewed my profile, viewed this profile, also viewed this other person's profile on LinkedIn, built on top of an Oracle layer. No Hadoop, no other fancy stuff, built on Oracle. And then we realized, we're like, holy crap, we can only run it once a quarter. It's kind of awkward. But then finally you say, okay, maybe we should build it on different infrastructure. Do you build it on Astrodata, Greenplum, Hadoop? Finally, over time, we were like, okay, Hadoop is really the right thing for this. We had to build a lot of other infrastructure to make sure we could do this quickly or repeatably. And this was a whole massive effort just that we learned from doing this. But we weren't trying to go after the crazy problem. We were trying to go after the problem that we felt was within striking distance for us. And when we were doing this, in the process of that, we realized we could be really opportunistic for wins. And one of those wins that's opportunistic is this thing of people we may know. People we may know was this idea. It came out from Jonathan Goldman, who was, Jonathan was a PhD, actually got his doctorate here from Stanford, his PhD. He came into LinkedIn, really amazing, clever guy. And Jonathan had this idea, it's like, and this is a time with social networks, where it's like you came to a social network, the very first thing, what did they ask you to do? Upload your address book. And you're like, really? On the first date? It's kind of awkward, right? Kind of a very glaring experience. So otherwise, the other choice was search for people. And you're like, if you just have an empty box, right? And you guys are all taught this, like that, okay, what name would you type in the first box? You got to think of something really tough. So instead, Jonathan said, we should just recommend people you should know. Or you may know. Not you should know, but you may know. And so everyone's like, yeah, that seems like an okay idea. That's pretty good. But we got all these other problems. So once again, no sophisticated technology. This is just off Oracle systems. Jonathan came up with the algorithm to do this. It's a real simple algorithm. Everyone thinks it's like whiz-bang craziness. The algorithm is the same one you ask somebody when you meet them at a party for the first time or a barbecue. What do you ask them? So what do you do? Where do you live? Where do you work? Where'd you go to school? Where'd you grow up? Triangle closing. Oh, you know Jeff? I know Jeff? Oh, we probably, that Jeff guy. Oh my God, right? that triangle closing. That's an algorithm. It's not hard to do. So he had this idea, and so he built out the results for everyone, and everyone said, yeah, we just don't want to build the functionality. So Jonathan, like a good data scientist, said, I don't give a rat's ass what you say. I'm going to do it anyway. And so what he did is he took over the ad slot on every person's homepage. And he gave you an ad, a fixed ad that kind of looked like that. Not exactly that one, but a variation. And so you got this ad. You could click on it, and it would take you to a page. Now, if you saw the ad, you'd see the same results again. But the crazy thing was, all of a sudden, the numbers went off the charts. Just crazy. It was just amazing. It was like, wow, this was a winner of a product. And it was just opportunistic. They recognized this. They were able to deploy it quickly. The system was built on Oracle. No fancy stuff, so it wasn't going to run the next day. And what happened was every other site, Facebook, Tagged, Ning, everyone suddenly was like, we got to have people you know. That is a transformative thing. And so suddenly you had one data guy with access to data transform the entire industry. And then you get into all sorts of these variants of all these other things like the friend list and all these other things that started to make it into even a more sophisticated state of these things. The point here is that being opportunistic opened up an entire space of things that you could build with the data and all this cool stuff that you could actually do. The other critical part of this is that small, tiny little product had acted as a massive lever arm for the entire business and all the other products that we were allowed to build. And so it gave us runway to teach us how to actually build it. And so one of the things that we learned was Oracle was not a good layer to build this on. We tried then to build it on Greenplum, and that didn't work. So then we tried to move it to Aster. And then finally we said, okay, you know what? This is really a Hadoop-style problem. And so then we actually built it on Hadoop. And then over time, it's actually built on a multiple of different things. And the way we figured that out was we were just fundamentally asking the question of, okay, can we run this every day? And the site is growing. And so we're like, running it every day is getting increasingly more difficult to run. And so we kept asking ourselves, what does it take? And then it was like, can we run it every 6 hours instead of that? Can we run it faster? Can we run it faster? Can we keep going? And that's how we started to figure out what type of technologies we also needed to use to support this. Make sure you give data back. Giving data back, it's an incredibly powerful driver for systems. And it really gets people motivated to interact with the site in different ways. One of the ways that was early done in LinkedIn was this idea of who's viewed my profile. So on LinkedIn, you can see who's actually viewed your profile. And it will give you a list of the people. And it's got this. And oh my gosh, there's actually cool graphs. There's all this kind of stuff. It's kind of useful. People loved it. Why did they love it? One, it was like we're taking all this data and we're actually processing it in a way that is actionable, that you could actually do something with it. And it also provided a monetization channel. So it actually drove people deeper and richer into the experience. You don't have to just do these type things. One of the powerful ways that we're seeing is a shift. And it's with the way people do it for marketing purposes. And so OkCupid is probably the best known of these. They have the OkCupid blog. And one of the things that they do is they talk about things like the mathematics of beauty, where they look at metadata. My favorite one is where they had the surveys of sexual, how often you were having sex, and they looked at also what type of devices you were using, whether you were logging in. So they had this kind of classic article saying iOS users have sex more often than Android users, and then there's the BlackBerry users, and then there's these Microsoft people. It is the Gates building. And the interesting thing about this, and when they did this, was think about what OkCupid was doing at that time. They were trying to convey why is it fun and interesting to use OkCupid versus eHarmony or Match.com. Those sites were trying to promise you soulmate for life. Here what they're doing is they're saying, look, we're fun, we're irreverent, we're being tongue-in-cheek. We're not trying to claim that you're going to meet your soulmate over here. We're trying to get you first dates. We're trying to get you, if you move to a city, it's fun. And so the data that they're displaying and what they're showing lines up perfectly with the vision of what they're trying, the marketing vision, the mission of that they're trying to accomplish. And you don't have to do that. We did this little one here. This is search for the hot job title, talking about ninjas. Monica Ragati from LinkedIn, she did this, and we put together this graph of the growth of ninjas on LinkedIn. So ninjas is being good. And then we said, if you're an event, don't be a guru, right? Change your profile right now if you have guru in there. And this little bit of data, like 6 hours of work, probably 15 hours of data cleaning, but 6 hours of work, really got us. This is the front page or the home page of the Wall Street Journal. Also get the front page of the Wall Street Journal newspaper. This is a time when LinkedIn, people were like, what's LinkedIn? Right? We couldn't get that kind of audience. So very quickly, just a little bit of data with some really pretty beautiful graphs. These ones were actually done in Tableau. We were able to actually get this information out there, and it got Suddenly people were like, oh, LinkedIn, jobs, understanding this, career. It matched perfectly with that. And since then, we've gone on and done a ton of more of these other things. But yeah, I have to caution you, make sure you don't do data vomit. Because we love data, we love to put more data out there. And it really goes simply, do not add more data to the page if you want clicks. And to give you an example of this, we took that previous version of Who Viewed My Profile and we said, we should give more data back. We're the data team. We should really be able to empower people with a lot more richness. Let's come up with a version. So we did. Here it is. It's amazing. It's beautiful. It's data vomit. It's got lots of recent viewers. We got even 3D pie charts, right? That's how you know we're winning. We got the companies, we got the industries. I mean, it's the percentages, the numbers on both sides. We're using every modality. It's like every textbook model. We like took Tefty and put it on steroids here. And everything here is drill down. Everything is drill down. So you know how many clicks this gets? 0. 0 clicks. Well, 1, because I knew to click. But it's why so little? Because you think all the data is already there. When's the last time you tried to click on an infographic? You don't. Right? The reason you don't is because you think all the data is there. So one of the things we found is the amount of engagement on a page is inversely proportional to the amount of data that's displayed. More data, less clicks. Yeah?
DJ, I have a question about that. So one thing that you could do with this page is make it all black. And to reveal any part of it, you've got to click. And that would probably generate lots of clicks until everybody left your site.
That's right.
And so I think one of the major data challenges on the web is how do you distinguish between no clicks being the greatest success you could possibly have and no clicks meaning meh.
Yeah. So the way the way I advise companies to do it is think daily habit. What's the cycle time on which people are going to interact with this? Is this a graph that I need to look at once a year? It's kind of like that end of the year statement that your credit card comes to you with? Or is it something like, tell me now, has something changed? Has something changed? How about now? How about now? I'm waiting for the day to change so I could get new information about me. That's like that dynamic that you want. You want people to really try to they wake up, first thing in the morning is they go check this out. And that's why it's having more of this actually shifts it. People love it. They're like, oh, this is awesome. I'm so glad you guys gave me all this information. And they'll never look at it again because it's that yearly report, not the daily habit. When you expose data and you put data out there in different forms, you really run into a set of unique challenges. And one of the ways I think that's best to articulate that is with this, this video.
Like Tebow thinks I'm gay.
What's Tebow?
It's a device that records television shows that you pick. And then based on what you pick, it records other shows that it thinks you'll like. You record Star Trek, Tebow assumes you like that kind of thing. And then when you're not home, it records the X-Files.
So what's the problem?
I had it record Will and Grace, a couple episodes of Ellen. Right away, the damn thing thinks I'm gay. Keeps recording Queer as Folk every episode. Last night, it recorded a Judy Garland movie.
Call the company. Just tell them you're not gay.
I want to be there when you make that call.
Exactly. I actually tried to outfox it, get it to go the other way. I had it record MTV Spring Break, Playboy After Dark, swimsuit competitions. Thing won't budge. Insists I'm gay. It's a problem.
So this is based on that famous blog post, My TiVo Thinks I'm Gay, where he was actually watching Ellen and a bunch of other shows. I think that's right. And then started trying to train it by watching Westerns, a lot of Western action movies, and then got Brokeback Mountain. And so he wrote about this. And there is this sort of funny thing, because we've all seen recommendation engines go wrong, like horribly wrong, like where you're like, what? What is that? I mean, it always goes wrong for me because my wife also uses my Amazon account. And so I'm like, wow, what am I being recommended? But there's a sort of moment there of perception and how do you actually deal with it? Because these things, when they go wrong, are incredibly, incredibly offensive to people. They can kill your entire user experience. And they're really jarring. And to get, especially let me give you a specific example, is if I recommend jobs for you on LinkedIn, and I say, hey, Michael's a professor here, and I say, you'd be good for an intern role. It's going to be like, what the heck? That's uncool. Don't you know who I am? Have you seen my CV? So people feel very jarred by that. And so much so that they will literally kill their entire time they'll ever use your product again. So how do you avoid that? And one of the most important things to do is to set the user's expectations in doing that. And the way I like to explain this is with these kind of two examples. Anybody know what this is? It's a Sony Aibo. It's a little dog, right? Pretty sophisticated data product. Taking in all these sensors, does all this stuff so that it can walk and bark. So why is it that way? Why is that important? Because if it walks into a wall, do you kick it? Do you say, this stupid piece of crap? Do you beat the crap out of it? It's got long ears, the robotic-looking dog ears. But no, it's got functional form. Think of that was a robot that was trying to bring you coffee, and it was in an Android form, and it spilled it on you. You'd probably beat the crap out of it. So what's the difference? This is a puppy. We've set the expectation of the user that this is a stupid machine. We're not setting the expectation like, I am the supreme overlord of data, and I'm going to tell you everything I know. Most of the time when you build products, and take a look at recommendation systems out there, and you'll see they do not act like this. They act like they're supposed to be super smart, super overly arrogant. They really don't have that touch and feel. Similar problem. Anyone try to call an airline company recently? Yeah, what is the first thing they ask you to do? Well, that's true. It's like you're in purgatory it's like, what have I done so wrong? Right? They ask you, like they say, like, press a number or say something, right? And you're like, and so you're trying to talk to it, and you're like, agent, representative, operator, human, what's the magic word, right? I just want to talk to somebody. And finally, you've entered all this information, you've given everything, you get to the operator, and then what do they ask? Can you tell me your name? So you've gone through this entire experience, and all the sophisticated IVR system, all the sophisticated technology that is doing all that processing does one thing, causes you frustration. Because that sophisticated data product is in the way of your objective. And the number of times we build data products and recommendation systems where we ask it for tons of information or put it in a presentation form where the sole purpose of that experience is to cause friction, does the exact same feeling when you call one of these airlines. So set the tone, set the framing of the conversation, make it feel stupid. Even if it's not, make it feel stupid, and make sure you're not getting in the way of friction. Always ask, can I drop friction? And with that same example, with a little twist, you can really take care of relevancy problems. So that example is, I'm going to build a module that says, hey, here's jobs you might like. And now, if I say to Michael, hey, here's this intern job role, and it's in the middle of Kansas, he looks at it and he goes, okay, this system is terrible. And it says, maybe it has a wrong tone, it has a wrong voice, but also, one, the seniority is off, recommending the wrong level. Second, he's like, I'm not moving to Kansas. That's a terrible recommendation. So now I've got two problems, because my system thinks it's good. I put all this effort into machine learning and all these other things, and it sucks at this point. So what I'm going to do is I'm actually going to build a specialized module for Jeff. And in it, it's going to say, recommend this job to Michael, because we think it might be good for him. So now, when Jeff forwards that job on to Michael, Michael has two responses. Jeff's an ass, or Jeff knows something that I don't know, and maybe I should really look into this. There's no third option of, hey, the system that we designed as a recommender sucks. We have totally taken ourselves out of the blame of the system. Teflon technology, right? And that's part of the trick, is how do you design with the tone, the voice, so that your system is not taking the heat? Because also, what I'm looking for is I'm looking for the interaction of what gets clicked now so that I can then take that and build it into the recommendation system. But I can't be precise because I got too much ambiguity. And so with this relevancy twist, I'm taking that off the table. Yes, data products have a very different development cycle. Right now, it's incredibly hard to test relevancy in production. I mean, the only place to test is in production, nearly. And so stuff goes bad real quick. This is an example of something called LinkedIn Skills. You've probably seen the variations of this. This is also what is known as LinkedIn Endorsements. This is a specialized page for it. And so you get all this crazy stuff. This is the one for ballet. And it's got all this rich information. It's got professionals. It got all this type of stuff. How do you bring content together? Because suppose we're building the page for cobalt. Well, cobalt, you mean the language? The metal? How do you do disambiguation here? Because when it gets out there, it's suddenly really tough. One of the tricks that we do is we build viewers, and we use humans to view stuff and just tell us like, hey, does this look weird in any way? And we're also then browsing it. In that same way that I was talking about identifying profiles as fraudulent or not, we're using all those ideas to actually view these things very efficiently to just see where things might have gotten funny and then go in and either hand tune because we don't know how to deal with the edge case. We're not trying to necessarily tune the algorithm there, or full-on retuning of the algorithm because it's too much of a segment that's being missed, or an ensemble approach. And finally, really know when to build the serious stuff. As an example of that, you post a job on LinkedIn, even still today, you get the 50 best matches. That product actually came out of an initial person's 90-day project. It was actually Monica. And what happened was she's just saying, hey, if you post a job, shouldn't we give you the best people? So that product built out on a slow system, little laptop. And what happened in that process was we didn't quite know what to do with it. We weren't comfortable with the relevancy. We really didn't know where to go. So we thought, well, we'll just wire it to an email system. And after you post your job, because we could only run this every 24 hours, 36 hours, we'll mail you a set of results. And in there, what we said is, hey, we're testing out this new system. We thought this might be helpful. So here it is. Here's some results for you. And people loved it. And then we knew how much people loved it because one day Monica didn't show up for work. And it was running on her laptop, and then we got these angry phone calls from the sales guys. And we're like, why are the sales guys angry? And we were like, oh my gosh, they sold it. They started selling this product because it was so good without telling us. So we're like, okay, well, we're winning. So what does that take? So we got to make it repeatable. Can we run it every 24 hours? So we finally got all the systems, all the architectures, all the things there. Started to work on relevancy, getting it right, got all that stuff there. And we're like, okay, great. Now we got that right. So I was like, well, it'd be great if we could get it down to 6 hours. So we get it down to 6 hours, we get it down to 4 hours, we get it down to 1 hour, maybe 15 minutes when the system's got low load. We're pretty good. Now when the teams work together, the prizes are saying, you know what we really need is this Pandora for people search kind of experience. We need to be able to say up, down, right away, this kind of notion of cards. That means real time. So I go, whoa. That is, we can't get, Hadoop is not built for this. We don't have the right type of technology. So now at this point, what we decide to do is we take apart everything. We rebuild everything from scratch. The difference here, though, is we know exactly which mountain we're climbing. And so we're able to go to the very specific thing. And that way, now it's a full-time, real experience and all that stuff. By the way, how long do we go till? 2:05. Oh, wow, we got a lot of time. I'm going much faster. So the second layer of this is, so that's in this product arc. So that's kind of the key things to know to actually build out a whole entire arc of product. The second one that I encourage you to think about is use this analogy of make superpowers. Always build superpowers. Because a lot of times when we build data products, just that same example of the IBO and calling the airlines, those aren't necessarily superpowers. So what's a superpower? Right now, if you take, I don't have my phone, but if you take out your phone, you think, hey, that phone's a superpower. The phone isn't a superpower. The Google or Apple Maps functionality on the phone is a superpower. Why is it a superpower? It's a superpower because you're allowed to, you can see where you are, you can see where traffic is, you can see into the future. You can take all those examples. Those are also very sophisticated data products. They're taking in lots of data. And remember, our definition of data product is the purpose of a data product is to facilitate the building of, or facilitate an end goal through the use of data. The end goal is to get you to where you want to be or know where you are. That's what we're trying to accomplish. So when you use a superpower that way, you're changing the whole perspective of what you're actually building to be user first. And you're using the data to make that into a superpower. So let me give you some examples. I think this one in the medical field, there's a lot of talk of saying we need to replace the physician. Our goal is to actually really replace the physician because we can come up with all sorts of algorithms and do all those things. I think one of the language that we should choose and really take a lesson from is really try to say, how do we focus on augmentation over replacement? If we look to those old Star Trek movies, there's a tricorder and there's McCoy waving this little thing over there. The computer isn't actually thinking ahead of you, right? It's not, or I shouldn't say thinking ahead of you, but what it is doing is it's augmenting McCoy, it's augmenting Spock. It's making them smarter by taking all this data and putting it in there. There isn't just a computer there that's doing it. Why think about it this way? When you're building the superpower so that you can actually understand the environment around you or what's wrong with somebody, what you're doing is you're freeing up the person who's using that device to actually do more. Why is that beneficial? Because one, if you've got this device and you're building a product today, whoever else sees this or the person who's using it is going to go tell their friends. Going to tell their friends. And so now you've got a channel for distribution. So people are actually going to go talk about it, try it out, play with it. It's also, which is another really important thing, products that work, people fall in love with. Can you really get love from your user as a product? And you build one of these things where it becomes something where it's like, if I took away your phone right now, it'd be one of those things where you'd say, oh my God, I can't live without this. How do I survive? So how do you get that love? And the way to think about that and that framing to do it is to ask yourself, what superpower are you building? And how am I augmenting you? You know, there's no computer that has sort of the strength of 10 men that replaces a Superman. It's Superman that has that power. The same way, as I talked about that, make us more efficient. And one of the ways to think about this is right now we've got all these plane systems. They're super complex. They're all super sophisticated. But really what we're trying to do is you get to the level of where you're doing high precision flying, especially if you're doing a fighter jet, you got heads-up displays. Let's take that analogy even a little bit further. You get to this. You want to fly this thing? What's the inside that? There's a massive heads-up display. It's like Google Glasses 2.0. And finally, the last part I want to talk about is this art of storytelling. I think the notion of storytelling with data and data products is so very, very poor right now. We're just not doing a good job of it. And so what is storytelling? And I think the definition from Wikipedia is actually a really good one. Storytelling is the conveying of events in words, images, and sounds, often by improvisation or embellishment. Stories or narrative have been shared in every culture as a means of entertainment, education, cultural preservation, and to instill moral values. Crucial elements of stories and storytelling include plot, characters, and narrative point of view. So with data, we can leave out maybe the embellishment part, because that lies, damn lies, and statistics. But the rest of it, I think, is something that's there. I can't tell you how many times somebody comes up and they'll present something with data or an idea of some idea that they're in, and it can just be a graph, and they've got no narrative. They've got no plot. They've got no characters. They've got no way of actually structuring it in a way that actually helps people retain the information. What are our products that we're building today to actually help people do that? We've seen this big transformation, especially a lot driven here with D3, of how people actually view and actually respond to different types of graphics, the way information is conveyed. We also know that it's changing is the way people actually tell a story about data. As an example of that, think about if you ever, I don't know if you've read Moneyball or watched the movie, know what it was like and what was necessary to get people to buy into that transition or that shift of thinking about it. One of the things people don't realize is LinkedIn was probably one of the least data-driven places I've ever met or ever come across. I mean, there was very little understanding of the site and the data and all those things initially. And now you look at it and you're like, well, what happened? What was the transformational change? What got people to think about LinkedIn differently? One of the big shifts that we did is we really focused on the art of storytelling. How do we actually convey information, both graphically, visually, and auditory? We really focused on that and how to do that. And as we started to do that, everyone started to realize, like, hey, there's a lot of power in this. And if we actually build products and actually use this to drive our business this way, we're going to radically shift the way we actually can build stuff and actually build a business. And so I'd encourage you, as you think about your products, how are you storytelling with that? And one of the ways to think about that is this idea which we call the zero overhead rule. And this came out of my time in security. And one of the observations we were working on with analysts, this is a couple years after 9/11, was people had come up with all these crazy technologies to help analysts to understand threats. And one of the problems that we found was everyone would come in and they'd say, look, I've got this amazing technology. And be like, great. And then they would say, oh, by the way, it only takes an analyst 3 weeks of training. You're like, 3 weeks of training? It's crazy. Who goes to training for 3 weeks? Anyone actually go to training recently for anything? Like HR training? Any of those type of things? No one here. No one's willing to pass it. You've got, like, what do you do in those training classes, right? There's somebody up there and they're presenting all this information. They're teaching you stuff. It's like the best time in the world to update your LinkedIn profile, catch up on Twitter. So like finally put likes on all the people that you haven't liked for a while on Facebook, right? It's like, thank God. And then finally you come out of training and you're supposed to go work on the tool or whatever. And you're like, oh God, I better go find somebody else who figured this out. It's horrible. Conversely, think about when you pick up an iPhone. Right now, how many pieces of paper does it ship with? I think it's about 5. They're all legal disclaimers. You know, back in the day when you bought DOS, it had like all these thick manuals. Right? Now we don't have manuals. This thing just teaches us. The people who are the best of the world at this, Angry Birds, yeah.
So that is entirely not true.
Okay,
Is that
go for it.
there are aspects of the iPhone which the first time you pull it out of the box are completely and magically obvious.
That's right.
And there are other things like how to shut off Bluetooth that the first time that you see it, you're like, huh, because it's a new user interface paradigm. And so you say, huh, where is that? And I think what's happened with a lot of modern products is that you've shifted from it ships with the manual to we assume everybody has the internet. And so what you do is when you get stuck, you just type shut off Bluetooth
put it in
iPhone.
Gmail.
And then somebody's got a web page or a YouTube video that has the answer.
Totally. So let's separate in there first-time user a funnel versus secondary and tertiary action layers. So in here, let's call out the first level. So because I completely agree with that. And so to take this analogy of Angry Birds, right? You can have a kid, particularly my kid, who doesn't really read and can kick my ass in Angry Birds, right? And he's never going to read all the text on there, even though it's so small and reduced. Now, you're absolutely right. If I tries to get to say, how do I defeat something on this particular level or that, he's going to actually go to Google and do those things. The part that what is there is what I'd argue is for zero overhead is, well, this is saying, when the user shows up and starts to use your product for the first time or interacts with a graph for the first time, how do you make sure it's not costing energy? How is it driven in there? Like, how do you think like a developer does, in particular around game development, so that you're teaching people as you use the product? Especially around data products where we're conveying or displaying rich content or information, that's done very poorly. Right now, I think the best data product that's out there is the weather forecasts. And what's the best output of the weather forecast? It's a little icon, right? If it's really sunny, it's got sunglasses on. If it's really raining, it's got lightning bolts coming out of the cloud. But that sophistication isn't one where I give you all the barometric pressures and all these weather maps where I have to teach you actually what to do and how to read those things. And so distilling it down, some people might call it even dumbing it down, and creating a funnel where there is no overhead so people can use it very, very quickly is an ability to get people to understand and drive into the product flows at a deeper level that then allows them to go to that next state. And finally, really, I think one of the things that we've been focusing on is how do we take the human out of the loop by building algorithms. I think one of the most important things we can do is try to start putting humans in the loop, whether it's empowering them by giving them superpowers, allowing them to storytell, to try new ideas, to play with systems, to be in control of their destiny. All these things is what's going to actually start to shift us in that data-driven world. The data products that are most successful are often the ones that help and aid a person and really focus on keeping you as a human in the loop and in the experience. And then actually finally, this is the one, for those that haven't read this quote from Ira Glass, and he talks about this whole experience of what it's like, and for him as a journalist in the narrative of storytelling. I won't go through the whole thing here, but I think the part that I would tell you that's most important about this, and you see this time and time again with storytellers, is how many times they have to try and iterate to get it right. In everything that I've talked about here, I haven't shown you all the places we went wrong. And we went horribly wrong. Like the time we were building groups for you, groups you might like, and we started recommending religious groups. That tends to upset people. Or political groups. All these type of things. And how do we actually fix it? And so build your systems in a way where expect that you're going to build it wrong, or build a relevancy, or have the tone wrong, and all those things, but make sure you have an ability to have a cadence or a style where you're actually going to be able to iterate on top of it to make something work more correctly fast. And yeah, and if you're interested, there's these 2 free ebooks on Amazon that talk a little bit more about some of these ideas, not all the stuff, but there's parts in there. Thank you. Questions? Yeah.
It seems like that one of the biggest driver of data products outside of social networking, which some of the examples you showed, is online advertising. Jeff Howard and others make funny comments. The best minds of our generations are locked up, serving us better ads. Given your perspective, what are the areas in which you'd like to see, where you think data products can play a transformative role, but that groundwork is really still being laid? What are you most excited about going forward?
Yeah, so it's interesting. I actually. I very often agree with Jeff. This is a case where actually I find most people are actually not working on ad products. I think in fact, it's far more rare to see people working on ad products. Separately from that, like what are people actually working on? I think is also stuff that tends not to be. There's a lot of things like restaurant recommendations and trying to recommend theater type things. Which are, think of things around the merchandising arena, which could be called a form of advertising. The parts where I think we'll see real radical transformation that I'm excited about, healthcare I think is just needs data, and the environments are just not data driven enough. I'm not sure we'll see that first in the US. I think we'll see it actually, I agree with Vinod that we're more likely to see it in India and the UK. Than any other place, just because access to data, consistency of data. General health, I think we'll see a lot more in. And one of the things, like the instrumentation of ourselves and being able to quantify what that means, I think it's still very early, and most of these devices it's very hard to tell how they actually benefit us. And I'm very optimistic about security. Probably people have heard more there was a recent story from the New York Times about the attacks out of China and the state-sponsored aspects of how cyber warfare is happening. I think security is and data will play a massive predominant role in that space. Mm-hmm. Yeah?
I'm trying to think through which of these heuristics you're presenting are particular to data-driven products and which are just good advice for any situation, right? Like low friction.
Mm-hmm.
Angry Birds has no data in it, but clearly, the fact that there's only one thing I can do, I can pull the bird back and it flies out, and I can inductively figure that out.
Mm-hmm.
As you point out, game designers have done this for a long time, and I'm not immediately convinced that data-driven designers are any different than software engineers typically are, from this perspective that you want to give all the power and none of the finesse by default. I wonder, is there a different solution in the data space here, or is it just that new people are coming in, so we need to repeat the old refrain?
I think what it is what I tell you is, so these are general product principles. What happens, though, is like, for example, how do you take a shift and twist relevancy? Or these things is because we know where, and what we have to be cognizant of is where the data products are going to critically fail on us. So for example, when tone is wrong with the data product, it has a much bigger impact. Or we can test other things in a QA environment, whereas data oftentimes, the interaction, it's very hard to do that. What I think is generally there is around data products is what I'd say is data products, the degree of difficulty is substantially greater than other product design because you've got software constraints, you've got the general product design constraints, and then you've got the constraints of the interactive layer of how to actually make it work with data, whether that's graphically or where you're trying to provide something and there's no data actually visible. Does that help? Another way to say it is, when you build data products, maybe one of the ways to think about it is what's it take to build data products at scale? Because one of the things that happens oftentimes is you put at scale out of this that says, I'm going to either repeat this regularly, repeat this at large volumes of data, or all these things. It'd be the same thing as saying, hey, when you're driving a car, you've got to really keep your eyes on the road. It's really different if you're driving the car around a racetrack at a couple 100 miles an hour. Like small changes made to really catastrophic impacts. And so these principles are things that we kind of have, but unless we're really, really focused on these aspects, it's very hard. It's very easy to make that data product fail very quickly.
And is that why you gave a heuristic that said, start simple. You never followed up by saying, eventually you get more complex. Most of the examples that we see
you post a job and you get the 50 best recommendations. That is a very complex one that uses every technology and every piece of the ones.
Technology is simple. Design is still very straightforward. It's a one-click interaction from the user.
Those ones actually are not one-click. They're full cards and very interactive. Yeah. The goal. So, sorry, it depends what you mean by the goal is very much driven to a single point action. Right. It is not an exploratory interactive environment, if that's what you're asking.
I suppose, yeah.
It's a very clear, we're trying to get you, drive you to a funnel. Because it's very action, in this particular, these flows, what we're trying to, in a lot of these things is, we're trying to drive you to a very crisp, it's very, you have a task, the data product is to facilitate that task. How do we facilitate that task is through the use of data.
I agree. We can take this offline. Often Photoshop is also trying to facilitate a very simple task, but there's a much richer interaction around it.
Totally agree. Totally agree. And I think there what you're also calling out is the difference between web properties and outside tooling as well, which is, yeah, we should talk about that one.
Photoshop users get happier, for the most part, when the tools do more and more for them.
Except for anybody that starts trying to use it. Then you have to go to Google and look for a tutorial. Yeah.
So one of the things that I've been thinking about with data in medicine is that it's slightly different than when you're recommending a job to somebody. If you're recommending a job to somebody and they don't like it, they're like, that's cool, I don't like this recommendation engine. When you start to simplify the data you're collecting about health and you start to say, oh, something more like you're going to have a heart attack, your heart attack meter is in the critical versus not critical, like that's I don't know, it's a more dangerous recommendation to be making.
So it's kind of like the relevancy part here, except with the notion of the stakes are much greater. And so how do you, like this is where I think it's really important to get tone and voice correct. And so is there a way to phrase the product experience where it says either, hey, we're seeing something we're not sure about. Is it the fact that you just really ate this cheese dog and kind of crazy nachos and you probably have indigestion? Or is it something else that's going on? So how do we have the product experience where we feel like, I don't actually know, but I'm going to propose this hypothesis. And you tell me if I'm stupid or not. Yeah.
I was wondering if you had any thoughts on getting a lot of this data analysis out of the hands of people who are designated as data analysts and into the people who actually may know a lot more about a specific problem within an organization, what the trade-offs are there, etc.
Domain experts.
Yeah.
So-
Whatever you want to call them.
So many of these times, these are built in partnership with those type of places. And I think the best data products are built with people who have some domain expertise. So, for example, if we're building a medical type example, building it with a team of physicians is really the right way to go about it. And sort of really, especially some very progressive types of people. For example, when we're building a bunch of stuff for security and national security type things, we're really working with agents and operators who actually own the problem at the end of the day. And our job is to make them faster and more efficient. They're the race car drivers. We're the guys building the car for them. Our job is to get them around the track fast as we can. How do you do that? Do you embed it? Do you build all these other tools for them? I'm a big fan of trying to empower these people through democratization of data. Facebook were the guys who did this really the first of saying, look, anybody can access the data. What we haven't done is build the tooling to really empower others to do that. And that can be on the cleaning of the data, like Trifacta is doing, of really like, hey, this is a hell job. We're going to help make this easier for you. To the analysis tier, where you've got things like R or IPython, where these things are just really, really tough to use. How do we make that easier for people? Mm-hmm. Yeah.
Hey, Jay.
Hey, I don't know, I'll ask this question the right way. I'm still kind of thinking about it in my head. But if you think about all these data storehouses as each having their own unique properties around business rules or legal rules or terms and conditions that were in place when the data was input into that storehouse. And in some cases, those terms and conditions can change over the history of the life of that storehouse. So certain parameters that get input have different terms and conditions around them than others. And in some cases, you're working with data storehouses that are the product of your own system, like all the stuff created by LinkedIn. And in other cases, you're working with external data storehouses that have different rules around them. So like in the software engineering process, how do you conceptualize the engineer's effort to deal with those business rules and legal rules? Is that kind of a separate analysis that takes place in the early stages of product design, or do you think about that as an ongoing function of the team?
It's a great question. And so one way to think about this question is, if you've got all disparate systems and the rule structure of, are you allowed to mix oil and water? Or is that okay or is that not okay? So one of the places where that's two places where that's really a big issue is one is in security, because we have a lot of legal protections around national security. Classified environments cannot be melded for privacy purposes, so you have to make sure that doesn't happen. And the other is with medical, in medicine. You may not want certain information being put together because it violates privacy, or you can have unintended consequences. I don't think that we know how to solve it yet. A lot has gone on to try to put provisioning into the data layers, but the master data, it's like one of the things is like it's part of the master data solutions and these other arguments. It's an open area of, I think there's opportunity to build a big company in that space. It's a very, very painful, yucky, messy problem, and I think it's open. Yeah.
So as a sort of add-on to Gilbert's question, so now we're building more and more tools, people here are working on that too, building tools to bring better analysis methods to kind of domain experts or like lay users by giving them the data and then letting them run the analysis. And kind of the next logical step would be, building more like push button tools to let them do that, because like R, IPython are difficult to use. So it seems like one of the difficulties there though is that lay users may not be as aware of the assumptions required to run a particular statistical method, or the things that may accompany their conclusions that aren't visible. So examples might be stats for a business analyst, or like another orthogonal example would be like the discussion on Reddit this last week about the bombers, and people not understanding kind of the social construct around what it means to do this type of analysis now that they have the data available. So how do you think we could design better systems to reveal that layer?
Yeah, I heard from there's a very big name CIO. He said, "I hope you're not proposing putting a gun in my kid's hand." And he was referring to his analyst, saying you're going to give them too much power. And so I was like, "Are you calling your team kids?" I think one of the things that's there is we certainly, it's almost a question of how do we do that the right way. I think Photoshop is a good analogy there, because if I use a diffuse filter, there's a lot of sophisticated math in there. You know, they might even use wavelets, or I don't know how they're doing it these days. But then nobody actually knows that they're actually doing that. So is it very task-driven, or is it very more broadly oriented? You know, it used to be back in the day, even when if you were going to compress something, it gave you the choice of compression that you would want. And nowadays, it's like, why would you actually give me a choice? I just do it. And I think that gets into a question of what's a specific problem versus more generalized power tools. One of the things is general that I've seen is if you take really sophisticated machinery and you put it in the hands of somebody who can play with it very quickly and try things out, they will learn the nuances quickly. One of the guys we had who was a business analyst at LinkedIn, really remarkable guy, no math training, self-taught, understanding of stats pretty poor, except for where he was self-taught on the specific things. And the guy had amazing insights. And he'd apply these things and he'd just kind of be like, oh, that's interesting. And he wasn't looking for p-values of slight significance. Like the stuff that we were finding was like, okay, that's totally obvious. Like we should do that, or that group, there's some problem here, or there's things like that. And so we weren't in the level, almost for every situation that I've seen, the result set that when you find something is so glaringly obvious, you don't actually have to apply the heavyweight machine learning, kind of like the nuances to it. What I think you do have to do, and the biggest problem is, people can't even apply the algorithms. It's too hard to just try different things. And so somebody tries to code it up out of some book or something, and it's just, they don't have a clue what they're doing, rather than trying 4 different versions, like kind of like a MATLAB or a Mathematic or a SAS or these type things. Yeah.
Follow on to Sanjay's question is, how do you enable people to catch bugs? Brad Myers pointed out to me years ago that if software written by pros and vetted by pros is extremely buggy, then how about all of the world's financial spreadsheets?
Just came out yesterday. 88% of spreadsheets have some bug, and a grad student can take down, well, it's not grad students taking down, it's like basically finding a flaw in a major thing. And what I think is it's like, one of the things that I always wonder is like, why isn't there a debugger in Excel, right? I mean, we have a notion of, one of the things I think that is terribly done right now is we don't have a notion of what QA is for tools. And QA can be, you can call this across the board. It's simple, like if we're doing PowerPoint, in between PowerPoints, you have transitions between every slide, and then one slide doesn't have a transition. Why doesn't it say, hey, I noticed you had transitions everywhere except this one. Did you mean that? Like, and having the right tone and voice. And I think we have totally neglected that portion across the board of every single product. I think all over the place.
So what are your thoughts on real-time data-driven decisions, meaning if you have more data processing capability, can you reach more decisions? So you're seeing real-time ads, millisecond time decision making or credit card checks, or even real-time security threats. Do you think we are making accurate decisions, or there is more mileage to it if we process more data?
Yeah, this is a great question about the real-time nature and pushing into the real-time aspect of things. The place where I see real-time really giving a benefit is alerting and fast triage on security systems. On almost all the other layers, I think there's a better product twist to do it with batch processing, or let's call it not millisecond. I mean, it can be in the minute range. I think you're plenty okay. The realm of complex event processing and those things, the only place where I have personally gotten big benefits and lift out of it, of changing and tweaking in real time, is on security and dynamic, and also ops monitoring for load balancing and machines and shifting things around for logistics at the hardware layer where you're doing stuff between data centers and virtual machines. Yeah?
Let's thank the speaker.
Thank you.